Hey guys, welcome back. Today is day 29 of this 30 days Leetcode challenge, and today's question is binary tree maximum path sum. So we are given a non-empty binary tree, and we have to find the maximum path sum. Now, the when they say maximum path sum, so what they mean is it can start from any of the nodes in the tree and end at any of the nodes, but the path must contain at least one node and does not need to go through the root. So it can be any of the path that may or may not include the root as well. So in this case, if you start from 2, 1 and 3, this is the path which gives an out sum of 6. Whereas in this tree, if you look, uh, the root has a value of -10, but if you look at an internal subpath 15, 20 and 7, so this gives us a maximum sum of 42. So that is what we have to code it up. So the tree node that is given to us is a normal binary tree. It has a value, integer value, and a reference to left and right subtrees. So now, in this case, the kind of information that needs to be returned from a node, this will obviously be solved in a recursive fashion. And the kind of information that needs to be returned from a node is what is the maximum path sum that it found in any of the subtrees, and as well as whatever is the maximum straight direct path that starts from the node of the subtree and goes up to the any of the length. So what is the maximum sum path that is direct, and there will be a sum path which will be passing through the root of the subtree. So that may if the value of the path in any of the subtree is actually more than the value of the path from its root from the root of the subtree, then the value of the maximum of these two values needs to be returned. So what we'll be doing is we'll be writing a class. So let's call this result as a class, and it will store two values which will be either a sum direct and sum that passes through the node. So sum of the path that passes through the node. So we'll be using and the helper function. I'll call this as path sum. So that will return me a result, and it will take a tree node as the input. Now if the node is null, then in that case the result that will be created will have infinite negative infinite values, so that will have the integer's minimum value. So the sum direct in that case will be integer dot min value, and the same way for the sum that passes through the node will also have integer dot min value. So, and that is the result that will be returned in this case. For other cases, what I'll do is I'll call path sum by passing in the left subtree, and call this as result left, and the same way we'll do for right subtree as well. Now we have uh, two choices. So we have to fill up the direct sum, which will be pretty straightforward. It will be maximum of whatever we found on the left subtree and right subtree, and add it with the value of the node. So the result object that will be returned. So let me create a variable which will be sum direct, and it will be max of uh, whatever result we found sum direct in the left subtree, and whatever result we found sum direct in the right subtree. Now since this values initially we are passing min value, So we have to do a max check. Uh, so we'll compare it with 0. So we may or may not include the left subtree sum. So this kind of ensures that, and at the end we just have to pass in the value of the current node. So that has to be compulsorily passed. The other is sum through the node, which will also be the max. We'll be writing a similar thing, but instead of doing a comparison between these two, we'll be adding whatever, if the left subtree has a positive sum and if the right subtree has a positive sum. So we'll remove this max and we'll say if the left subtree has a positive sum, then add it to the positive sum of the right subtree, and always add the value of the node. So now this is the sum of the value, the sum that passes through the node. But what if we have found in the left subtree or right subtree already a value that is more than the sum that passes through the node? So in that case, the sum through node will actually be max of uh, its current value, and we'll compare it with whatever it found, the sum through node that was found in the left subtree and in the right subtree. And yeah, so we'll fill up these values in the result. So the sum direct will be whatever sum direct we calculated, and the sum through node will be the updated sum through node that we found, and the result will be returned. Now for the final root component, we'll have to compare these two values and return whatever is the max we found for both of them. So I'll create the final result. I'll say path sum, and I'll pass in the root itself, and I'll have to do a max for the sum direct, and in the result the sum through node. So the maximum of these two values will provide us with the result. So let's run this and check. So it works for if the root contains -1, -2, and -3. So it works for negative values, and that was the primary reason, because negative numbers are involved. We have to return min value. Otherwise, if only positive numbers were there, then we could have directly used zeros in this case. So if I submit this, then our solution is accepted. So thank you guys. If you like this video, give it a thumbs up, and do subscribe to my channel to be notified when I upload tomorrow last day's problem. So tomorrow will be the last day, 30th problem that will be uploaded. So yeah, thank you guys. So this is day 29th problem.